I recently received this from Fnirsi. It's the AC/DC Intelligent Digital Control Power Supply, model IPS 3608. Today I'm going to unbox this unit and give it a review. So let's go. So, full disclaimer, I purchased this myself, so it was not supplied to me by Fnirsi. I'm not being paid to make this review. So let's start by opening the box and see what's inside. Okay, we have an accessories box. And we have the unit itself. So I'll just put this box to one side. Okay, so we'll start by looking in the accessories box, see what we get. Okay, I've got a power cord which is not suitable for my region. Got a couple of power leads, so these are banana type leads with a decent crocodile clip on the end. They seem to be quite reasonable quality. They're not silicone, they're PVC, but they're reasonably flexible and look like they should be capable of 10 amps. We have the instruction book and a USB-C cable. Just compare that to what the instructions say that I should have, if they indeed say, which they don't. Okay, right, let's open the unit itself. It's in a plastic bag. Okay, so first impressions, it's quite compact compared to some of the other power supplies that I've got in this range. It's got an air vent at the top, but the vents at the bottom actually have a piece of perspex covering the actual vents, presumably so you can't put your finger in there and touch anything. It does have a cooling fan on the back, but it would probably be nice if these vents actually had some kind of mesh inside them to enable better cooling. So I can see that there's a big heatsink type thing under there. Anyway, on the other side, yeah, it's exactly the same. There are some cooling vents on the sides, on this side, which would be the left side of the unit. And looking inside there, I can actually see, yeah, actually it looks like there's an inductor in there which is really quite close to the mesh. Now whether that's a plastic mesh or a metal mesh, I'm not sure. Might have to investigate that later. The front of the unit, the display actually tilts, which is quite nice, although I have to say that it doesn't maintain its full motion, so when you push it fully one way it does kind of spring back a little bit, more so at the top, so that's not fantastic. The buttons, yeah, standard. I think it's got an encoder with a push button on. And the back of the unit, we have the fan, as I said, on off switch. Personally, I think I prefer to have the on-off switch on the front, but there you go, that's my preference. Power connection and USB-C on the back. Not quite sure what that is for. Presumably this cable goes with that. Maybe there's some software, maybe you can connect it up, or maybe it's just for firmware upgrading. We'll look at that later. One thing I do notice is that unlike most power supplies of this nature, it does not have an earth socket on the front, which is kind of unusual, because normally you have an earth socket on the front and then a linking bar, so that then you can reference your negative supply down to earth or not by removing the linking bar. So that is one thing that I do notice. With that being said, it is a metal case with metal screws which are all painted. I am wondering whether the grounding is actually any good on this or not. Right, let's just do that first. So just do a simple test to start with. We'll just see if there's any continuity between the ground pin and any of the screws. Yeah, there is. It's a little bit on the high side. Let's just penetrate through the paint a little. Okay, so the screw in the bottom has good continuity to the earth pin. The screw that holds, oh yeah, that's good also. So it does appear that the continuity is actually okay. The anodizing is an insulator, so let me just pierce through that, and yes, I do have earth continuity to the actual case itself, so that's actually okay. So I'm happy with that. It's just that there's no earth pin on the front. So is the ground, let's see if the ground or the negative terminal is referenced to ground. No, it doesn't appear to be. To be honest, that's normally how my power supplies anyway, with the negative DC output disconnected from the earth. Right, okay. Right, I'm just going to zoom out a little bit on the camera so you can see a little bit more. Okay, so I've got this propped up so you guys can see it a little bit better on camera. Hopefully it doesn't fall down. I just want to show you the tip feature of the screen. So on this particular unit, when you push it down, it kind of stays there but does spring back a little bit. And when you push it so it's pointing up, it just pretty much goes back up vertically again. So on this particular unit, that function is not good. I think the cables are being pulled, so I would imagine that's actually an assembly problem. So I'll look into that when I take the front off. I'm going to plug this in, and the power switch is actually on the back. I won't show you me plugging it in on camera because I want to show you the front. Right, so I'm going to plug this in and I'm going to power it up on the dim bulb to start with, just to see what happens. I'm going to try and hold my mobile phone up at the dim bulb while I'm switching it on, and then I can show you that footage hopefully. So let's get my finger on the power button. Right, record on the phone. Okay, let's power on. Okay, so that's the power supply as it's powering up. And then with the dim bulb off, just on power up, the device's current draw is about 20 milliamps. Okay, so it's asking me to set the display language. Presumably we can just change that and then press the enter button. Right, so initially the first screen displayed is displaying voltage, current and power in watts. It's also got the voltage set point, the current set point, and the presumably that's the internal temperature, 23 degrees. It also has a sub display showing capacity in amp hours, energy in watt hours, and the time. So button wise, it's not a touch screen. So what can we change here? So the rotary button changes between screens, and it's got 3 screens. So it's got the screen that it's also got some small icons here indicating volume, probably the fan, and it's got a lock. Whether you can lock the keypad is possible. The second screen is like a graphing function, and then the third screen has just a different layout, so it's showing you the volts and the current. Oh, the A and C, right, okay, I believe these are for the USB ports. USB A, so showing the voltage and the current and the capacity, and then the same for the USB C port. It's also showing the mode of operation, constant voltage at the moment, and then the output voltage and the output current. Okay, so we can change the set point by pressing the VA button. So we can select the voltage, we can go across, select the output voltage, say 15 volts, and then the output current, yeah, it's 1 amp. Okay, so that literally just alternates between those two. The up and down buttons don't seem to do anything. Okay, this arrow button stroke, I assume that's a setup cog, goes to the data set points. So it's got 6 set points where you can set the output voltage, the output current, OVP. Okay, so it's the maximum voltage, the maximum current, the output display power or the output power, and the maximum temperature. So I assume that these are variables that you can configure. Yeah, so you can configure it to go to a maximum of a certain voltage in any particular of the data set. Okay, so then we have the system setups. We've got the language, the brightness, volume. I will actually turn the volume down because that annoys me. I'll put that on 35%. I can hear it, don't know if you can, doesn't matter to me. Okay, meter and switch close, not sure what that is. Device address, don't know what that is. And then we've got probably a display mode of dark mode and light mode. Okay, I'm more of a dark mode kind of guy, so I'll leave it on dark. And then the final, we've got the about, so it's got we can do a factory reset. It's got the model number and the current version of the firmware, which in this model is version 1.3. Other things to note, I do have a red light on here, don't know why that is, and the output enable is a button here, run stop. So let's go to the main screen. So let's turn so I've got an output voltage set of 5 volts, current limit of 1 amp. Let's turn the output on. Okay, so the output becomes green when the output is on. Yeah, I'm not sure, that's a matter of preference whether you prefer that to be green or red. I think personally I prefer it to be red, but you know, that's neither here nor there really. I'm going to connect up a meter and we can check the voltage and current outputs. So I'll go ahead and do that right now. Give me a moment. Okay, so I've got the meter connected up to the Fluke, DC volt mode. So let's just check the kind of the basic accuracy of the display itself. Oops. Try and hold that so it's visible on camera. Right, so output on. So I'm currently set at 5 volts, and that's in fact 5.02. So that's and to adjust that, I think I have to press the VA button. Yeah, it's got the displayed voltage here, so we should hopefully be able to turn that up. So let's go to 10, well, 10, and that is actually spot on, 10 volts. 15, spot on 15. 21, 21.01. Let's go 30. Yeah, spot on 30. And the maximum, which is 36. Yeah, let's just go down. I think we can change. Yep, so we can go 100 milliamps. It's 104, 200, 900, and then let's go. What's the lowest we can go? We go at 20 millivolts. That's displaying 24. And at 60 millivolts it's also displaying 64, so that's pretty good. So I've now got the meter connected in current mode, and we'll just do the same thing but with current. So let's start quite low. Let's start at 100 milliamps, power on. Yep, spot on 100 milliamps, 9900. Okay, let's go 20 milliamps. Yeah, it's perfect. 60, 90, and then let's go 500. Oh, 500 milliamps, and that's 499. Let's go 1.5 amps. Yep, perfect. 3.5, perfect. 8.2, perfect. The actual display on the unit itself is very accurate, and the fan has just kicked in, and I think that was about 33 degrees. Okay, output off. And we'll just see what temperature the fan switches off at. It's currently 37. Yeah, the cooling is actually quite slow, I would say. The cooling effect is quite slow. The fan itself, you can probably hear it. It's not terribly noisy. It is actually relatively close to the microphone, so it might come across a bit noisier than it is in reality. Temperatures at 35, and the fan indicator has come on the front to symbolise the fan being on. .33 degrees. Yeah, the cooling effect is actually not all that good. .32. 31, the fan is still running. The ambient temperature in this room is it's approximately 22 degrees. wonder if I can wedge something in there to keep it tipped back for now. Okay, fan is just switched off at the point where it dropped to 22 degrees. Okay, I've wedged the little plug in there, and that makes it a bit easier for the camera to see the screen. Yeah, the next thing I'm going to do is just put a load on it. I want to see how quickly the temperature rises when I put some more load on. So I'm just going to go ahead and do that. Okay, I've got an electronic load connected. Unfortunately, the load itself does actually have a cooling fan on it, so you can hear noise from that as well in the video. Well, you should be able to see the fan icon actually on this unit, and hopefully you can see the temperature, but I will read that out as well as the timestamp. So I just want to get an appreciation for how quickly this thing is going to rise in temperature when we put a bit more of a load on it. Okay, so the fan has just turned back off again. I've just let the device cool back down, so we're down to 29 degrees internal temperature. So what I'm going to do now is I'm going to wait for an appropriate time on the display, and then I'll start the test. So I've got my electronic load set for a current limit of 8 amps. We've got the output voltage set to 18 volts, and the current limit actually on the power supply set to 8.2, so it will actually operate in constant voltage mode, so we can get constant power. And then I will start the test and then monitor the temperature rises, and I'll read out the actual temperature every minute just so we can get an estimate of what that's going to look like. So I'm going to turn my external load on now, and we'll start the test now. It's on 8 minutes on the clock. We can see that we're pulling 144 watts. The voltage at the end of the output cables is 17.7 volts. The internal fan has just started at 33 degrees. Yeah, so we're losing about 0.3 of a volt across the cables. Okay, so at 1 minute we're up to 42 degrees. Okay, at 2 minutes we're up to 51 degrees. At 3 minutes we're up to 57 degrees. Okay, so the output has actually switched off at 58 degrees. So I'll turn the output off, and I can hear a buzz coming from somewhere, and the time has stopped, and now the device has actually locked up, so none of the buttons are operating. And there is a beep coming from the machine. I'm just going to leave this until the fan on my electronic load switches off so we can actually hear it ourselves. It is a very windy day here also, so I've got quite a lot of wind noise in the workshop today, unfortunately. I'm just going to turn that off myself. Okay, yep, so there is a continuous beep coming out of the Fnirsi power supply, and it has in fact locked up. It's totally locked, it's not. So the only option is to go to the back, we'll turn the power off, and then turn it back on again. So it's started up with the output red. Fan is still running. It's an internal temperature of 55 degrees. So it would appear, and I'll have to go back onto the footage to confirm, but I think this temperature gauge said 58 degrees. At that point it automatically switched the output off, and then when I pressed the stop button the unit froze. I'm not going to repeat that test right now until I understand a bit more what's going on, but that certainly is not a good sign. What I'm actually going to do next is I'm going to get a scope out and connect a scope up so we can actually just look at the ripple on the output at various load currents. So I'll go ahead and do that now, and I'll let the unit cool down a little. Okay, so I've got an output voltage of 1 volt and an output current of 1 amp. The ripple appears to be around 200 millivolts peak to peak, and the frequency appears to be about 91 kilohertz. If I increase the output voltage, now what I have noticed something else that I don't like about this guy. I'll show you in a moment, but let's just output the voltage, let's put it up to say 20 volts, and the ripple has gone up a little bit. I'm on 50 millivolts per division. Let's just go, let's go to 100 millivolts per division. That's not the best waveform for me. Let's increase the current a little bit. So let's go up to 5 amps. The ripple has gone up. It's very, very messy. Okay, let's do a few, let's turn that load off. So let's do a few very slow traces now. And see what the power up looks like. I will change that to DC coupling so we can actually look at the output. DC. Okay, so I've got the scope running the slow trace so we can look at the regulation on startup and shutdown. So I've currently got the output set to 15 volts and a current limit on the load of 1 amp. So we'll turn the output on. We can see that the output goes up nicely, maintains, and then we'll turn it on. So yeah, so it is actually dropping slightly negative when you power it down. Let's just slow down the trace a little bit. So power on and just power off. Yeah, so it does actually drop down a bit negative on power down. Right, let's increase the current to 4 amps. Start the trace and power on. Yep, goes up good, goes up nicely and drops down again. It's a bit of undershoot and it slowly creeps back up to 0 again, but that's not too bad. Right, let's increase the current again to 8 amps. The fan is still running, it's at 32 degrees temperature. Okay, power on. And yeah, that's pretty good. And power off. Yep. Right, let me increase the voltage. So we'll turn the current back down to 1 amp. And let's increase. So what I was talking about, if you press the voltage or current button to enable to set your output, You can set your output, that's fine. So let's go up to 33 volts. But after a short period of time, it actually times out. So then when you think, oh, I'll just adjust the voltage again, it's automatically timed out, and then you just scroll through the screens. For me, I'd like for that to stay in that mode until I press the button again and then exit out, but that's just my preference. Okay, so I've set the output voltage at 33 volts, 1 amp load, power on, and again the rise is quite stable, and again, yeah, it's a bit of an overshoot, bit of a wiggle, or an undershoot, a bit of a wiggle, and then stabilizes at 0.3 volts. Okay, let's put the current up to, I'll have to be a bit careful. Let's go with 4 amps on this voltage with my lows, and output on. Yeah, there was a little bit of a hesitation going up to voltage, and output off, and again slight undershoot, slight recovery. So there is a little bit of a step on the way up. I will just quickly do a power on, power off test with no load connected. So I've literally got the scope connected to the output of the power supply. So power on, I've currently got 5 volts set. Yeah, again the power on looks quite good. Let's just speed that trace up a little bit, just see if we can catch anything. Yeah, what I will say is when there's no load on, then the output doesn't go negative, it actually stays a bit positive and slows and drops off much slower, which I guess is understandable. Let's just connect the fluke up to that so we can see that in voltage. The fan has just turned off at 29 degrees. Okay, so we can see the output voltage on the fluke. So I've currently got it set for 5 volts. Power on, 5 volts, and power off. Yeah, so it goes down to about 0.2 of a volt quickly, and then trails off to 0 over the course of a couple of seconds. And let's just increase the output voltage to maximum, do the same tests. So currently got for 36 volts output, and power on. Yeah, so there is a little bit of overshoot there. Let's just drop that down so it stays. Yeah, so at maximum voltage, let's go and capture it all. That's okay. Is it because I changed it? Yeah, maybe. Yeah, it's not entirely consistent, but I think it's fine. Okay. Okay, so one more thing that I would like to have a look at before I go on to the USB ports. This device does have a graphing function. And so it's quite straightforward. I think it continuously plots the voltage and the current curves, but it does have an adjustable time base I can see here. Not quite sure how to adjust that. Oh, here we go. So the left and right arrow buttons increase the time base. So we've got 0.5 seconds between samples to 0.1 seconds between samples. I have literally just got the flute meter connected back up in 10 amp current range. I've got the power supply set to 5 volts, output of 1 amp. So let's have a look at the graph. Yeah, so it's set for constant current mode at the moment, so it's showing the output current at 1 amp here. If I just disconnect that for a second, let's just have a look at the voltage plot as well. Yeah, and I should be able to adjust that from this screen as well. Yeah, I can. So I should be able to adjust the output voltage, 15 volts, and we can see the traces gone up, 20, 25, and it's gone to 0. Why has it gone to 0? So I must have over voltage set on one of these screens. M1 data set. Oh yeah, over voltage protection is set at 23.5 volts. So let's just put that. Oh, in fact, what's the data set? M2. Okay, data set M2 is back to the standard. Let's go to dataset M2. Okay, so I've changed on to dataset M2 here, so hopefully now it won't shut down the output when I go up in voltage. So yeah, okay, so it goes up to maximum voltage now. Output on. And let's put that back down. So let's put that back down to 10 volts, reconnect the meter, so 10 volts, and then we can see, because we're in constant current mode, the output voltage has dropped down to 0.13 volts, but the current is at 1 amp. So the plotting function works pretty well. Let's just change the time base, slow it down, so should be in constant voltage, 10 volts, yep, and constant current 1 amp. Okay, yeah, that kind of works, so could be useful, I guess. And the fan has just switched back on again. So literally outputting, how many watts are we outputting? 0.13 watts, and yeah, I suppose it's because we're dropping loads of volts, but even so, the fan has turned back on. Right, okay. The next thing I'm going to do is quickly test the USB sockets. So for the USB-A socket, I've got one of these simple USB-A monitor, and then I've just got a little USB-A variable load. I think this thing goes up to like 2.5 amps. I haven't checked the rating of the output. Let's just have a quick look at that, see if it says in the book. Just says what standards it is. So USB-C is PD3, and the USB is Huawei FCP, Huawei SCP, AFC, QC 2.0 and QC 3.0. I'm just going to test that up to 2.5 amps, so I think that's more than adequate for USB-A. So let's plug this in. Okay. Right, so yeah, I think, yeah, so it would appear that actually the socket is really the wrong way around for this kind of tester, which isn't ideal. So there's absolutely no point plugging that in because that's not going to tell me anything. So let's go to the USB screen. I have no idea what this is set for. Let's just turn the control a little bit. Right, so presumably I have to plug this in upside down as well. Yes, I am. Right, okay, so we've got it set for 1 amp, which it seems to be supplying quite happily. Let's turn this up to see if I can get some more out. Monitoring the output voltage. The output voltage is creeping up a little bit. Okay, 3 amps. So at 3 amps, the output voltage is 5.33 volts. And let's just turn that back down again. To half an amp, which is more standard for these. Yep, so at half an amp, the output voltage is 5.14. 3.3 is as most as I can get out with this device. I'm not saying that is the maximum current it will supply. Output voltage there actually seems to be lower this time. I've now just noticed that. Let's just turn that back down to 3 amps. Yeah, so I would say that it's nearing its limit. So at 3 amps the output voltage is 5.33 volts. If I crank that up to 3.3 amps, then it's actually dropping down again to just over 5 volts. So it would appear that it's meeting its, or getting close to its current limit. So let's just put that back down to 3 amps. Thereabouts. And the fan hasn't kicked in yet. This guy's got a little fan on which is running, so if you can hear a fan, it's just a little fan on this. I don't know if we can monitor the temperature. Yes, we can. 30 degrees. So again, the USB outputs are on regardless of the status of the main output. Yeah, the internal temperature doesn't really seem to be rising very much, if any. It does actually show us the status of the main outputs on this screen as well. So presumably, if we turn that on, yeah. So we can actually have the main output on as well and monitor that while we're actually monitoring the USB, which is kind of good. Okay, my little load here is starting to get warm. The fan has just increased on that, so it's starting to get a little bit noisy. But I think that looks fine. So I'm going to stop that test now. Okay, so to test the USB-C, I have here a PD USB-C soldering iron. So let's plug this in. I have actually just had it plugged in, so it's a little bit warm already. So this can negotiate the voltage. You can actually set any voltage, well, set various voltages. It's currently negotiated 20 volts, which is, I believe, what it's set for. And the device is actually pulling about 2 milliamps. So if I press any key to start, voltage set, yeah, so that's currently set for 20 volts. And then if we can go down to 5 volts, and yes, it has negotiated 5 volts. And at 5 volts it's pulling about 3 watts, 9 volts. Okay, so at 9 volts it should be around 1 amp, yeah, so about 9 watts. Okay, 20 volts, so it's about 50 watts. Yep, 12 volts, yeah, around 20 watts. Power on. And yeah, about 2.3 amps I saw there for a moment. Okay, so that seems to work quite well. Okay, and the last thing I want to do is I want to pop the front off to see why this display won't go where I want it to. We'll have a quick look inside while we're doing that. Okay, I'm going to actually take the front panel totally off, so I'll do that off camera and I shall be back in a moment. And a quick look inside the unit, we can see that there's a switch mode power supply in there, and there's a fan at the back. It's all aluminium heatsink on the switch mode power supply. Looks to be quite decent quality construction. And again, the front panel, I'm going to actually have to remove the front panel. I can't, it's impossible to see why that isn't opening. I can't really even see where the cable goes. Okay, so it does actually have a ribbon cable on the back of it, which is this guy right here. So is that what's stopping it? Not sure that it is. Let's see how much effort it actually takes to take the front panel off. So with that disconnected now, it still doesn't really want to rotate. So let's actually have a look in here. And the screen comes out. Yeah. So I don't know if you can see that, but I've actually got cracking on there. Let's just change camera. So that's actually cracked. Yeah, so what it looks like to me, I don't know if it's the same for all of these, but it certainly looks as if, yeah, so the way this is designed is that this this fixing actually needs to rotate, and it does not. Yeah, and it's actually been held in with some kind of adhesive, so there's actually like a thread locker on there, which has caused that to basically destroy itself. In fact, that's keyed. That's actually keyed. So how is that supposed to rotate when it's keyed? No, I think this is a definite design flaw. Maybe I have a faulty unit, but I don't think so. So this is the fixing. There's a small screw that goes through there, to hold it into the front panel. But when you rotate the screen, that fixing rotates. Okay, so in order for that to actually rotate and not break the plastic, it should freely spin inside the screen, but it's not doing that because it has a key and there's a slot inside the screen. So when they're keyed together, that stops that from rotating, and then when this screw is inserted into the front cover, that's fixed. So any rotation on the screen is just going to cause it to break, just as it has. So there's definitely some kind of design issue going on there. Okay, so what I've done is I've removed the key from the little piece of metal there, and I've reinforced the screen. So I'm going to put that back together. Okay, so I've reassembled the screen into the casing, and now it does in fact tip and stay where you've asked it to go. So I would consider that to be a success. Okay, the unit is reassembled. Just a couple of things to note on the PCB here. So there's one replaceable fuse. In fact, there are two replaceable fuses. This one is 15 amp. That one is 16 amp by the look of it. And the fuses themselves. So the fuses are 6mm by about 2.5. 6mm by 2.5mm. So yeah, so I just need to connect this back up to the power supply, and hopefully it will still work. So I'll just go ahead and do that now. Yeah, it's good. 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 Okay. And let's just power it up to see if it still works. Yes. And now the screen does in fact stay wherever you put it. Right, I'll just pop the screws back in the front panel. Okay, so while I was in there, I did look at this, the mesh that's in here, and it is actually a metal mesh, and there is an inductor winding that's relatively close, but I did actually check, and there's I reckon there's about 4 to 5mm of clearance in there, so I don't think that is an issue on this unit, although it's a little bit closer than you'd ideally like. So I think in summary, the unit is actually, well, fundamentally it's quite a decent unit, but obviously I have found a couple of flaws with it. Firstly, I believe the USB-A socket is the wrong way round. They are in fact the correct way. I will try another device. I have got another one. I will try another one to see if what I'm actually saying is true, but I'm pretty sure that is. When I did the load test, the extended period load test, after a short period of time, presumably when the internal temperature got too hot, and that was only at 144 watts, the output switched off, and then when I pressed the run stop button, that caused the whole thing to freeze, and the only way to get out of that was to power it back off and back on again. And the third thing, for my unit, I assume that they're all the same, that needs a redesign, is that my screen would definitely not stay where you put it. It would just spring back, and as I showed you on the video, that's what I don't like about it, which are quite serious flaws, to be honest. So I don't think, on this occasion, as this unit stands at the moment, I cannot recommend it. That is my final verdict. So I hope you enjoyed watching the video on the Fnirsi IPS 3608 DC power supply. If you enjoyed the video, please give it the thumbs up. Comments are very welcome on this review, and if you enjoyed watching the video, please subscribe to the channel and check out my other videos.